If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in differentiation, that is method of differentiation. So in this lecture we will see how to find derivatives of inverse function and their relative formulas, and we will also see what is logarithmic differentiation, where it is used and how to use this one. Okay, then let's see this. Now inverse function and their derivatives. Okay, so suppose f, the inverse of the function f and g are defined as standard definition y equal to fx or x, then x can be written as g of y, another function. From y to x we are going, now we are coming from x to y, so it is the inverse f, g is the inverse of f. And if f inverse exists and f inverse is not equal to 0, then g inverse y is f dash x exists, that means differentiation of f exists, and differentiation of f dash, that means derivative of f doesn't vanishes, that is doesn't equal to 0. Then differentiation of that inverse function is the 1 by of that original function. So inverse function differentiation is inverse of original differentiation of original function. This can be also written as, suppose dy dx exists and dy dx not equal to 0, then dx by dy, that means inverse differentiation. If you differentiate this one with respect to y, now here y is the variable, dependent variable, x is dependent variable, y is independent variable. Now if you change y, you can write it dx dy. Here it is dy dx because you are changing x is input here, y is output, so it is dy dx. Here it is dx dy because y is input, x is output. So dx dy is 1 by dy dx, provided that this dy dx should not be equal to 0. So dy dx is a differentiation of this one, so this is inverse one, so this differentiation is 1 by of this differentiation. That's what they have told you. Or you can think dx dy or dy dx equal. Don't think that these are cancelling out. This is from the inverse theorem only. So dy dx is 1 by dx dy, again provided dx dy should not be equal to 0. Now from this you can find the differentiation of sin inverse x, cos inverse, all these inverse trigonometric function. Differentiation of sin inverse x 1 by this. So let me prove how from where it is coming using this theorem. Y is equal to sin inverse x, let me take it fx. So if you find x from here, so x will be equal to sin y or x equal to sin y. This is gy. So this is the inverse function. This is original function sin inverse x, and sin y is inverse function. So if you take differentiation of this one dy dx, so it is d dx of this one. We need to find this one. That is my requirement. So it is dy dx is 1 by dx dy. So let me take dx dy here. So if you do differentiation with respect to y, so it is dx, differentiation of x with respect to y. So differentiation of this with respect to y, sin y is cos y, so dx dy is cos y. So dy dx is 1 by dx dy, 1 by cos y. Now what is cos y? If sin y is equal to x, then cos y will be equal to under root 1 minus sin square y. And sin y they have given already x. So you can find dy dx is this one. Similarly all these things can be proved. But don't need to prove, you directly remember all these formulas. These are very important formulas, but all this coming from this. That means the differentiation of the inverse function is the reciprocal of the differentiation of its original function. That's the idea. So differentiation of cos inverse, tan inverse, you can see sec inverse, cosec inverse and cot inverse. All this range also you think, because x should be between minus 1 2, because under root it cannot be negative. Here also under root it cannot be negative, it can take any value. Here mod x should be greater than 1, this one cannot be fraction, otherwise it will be negative root. Same here also, here it can be any value. Okay, next you come to logarithmic differentiation. Logarithmic differentiation means to find the derivative of, there are two cases, case 1, case 2, but generally we don't go for case 1, we generally go for case 2 because it is mandatory. Here you can apply, but we don't generally apply, but here you should apply this one, without that it is not possible. So case 1 is when there is a product or quotient form s. There are number of functions, more than generally 2, 3, 4. For 2 it is easy because we will apply product rule or quotient rule. Suppose I have taken a simple example, it is product of two functions x into sin x. So generally what we do, you can apply log both sides. So log y equal to log of this, log a into b is log a plus log b. So if you differentiate it with respect to x, then here one thing I skipped here. Here y is equal to function of u, then dy dx is function of f with respect to u, then you differentiate of u, something sort of chain rule format in general. So here also you will be applying that one. First you differentiate, because you are differentiating with respect to x, but here no x, so you treat that this is x. So log of differentiation is 1 by x, so you treat this one as x. Now next you differentiate y with respect to x, so some sort of chain rule, because there is no direct relation of y to x, so you can differentiate in this way. You treat this one as x, 1 by y, then you differentiate of y with respect to x. What is differentiation of log x 1 by x? What is differentiation of log? Here it is composite function. First outer function is this one, inner is this one. First you take care of r. What is outer one, log differentiation is 1 by x. So treating this one as x, 1 by this into, and then differentiation of sin x cos x. So it will look like this. So your dy dx, because I need to find dy dx, so you send y this side, y into this. Again you put y equal to this, so if you take product, this is the answer. But generally you don't go this way, you will do product rule, because this constant differentiation of sin is cos and this constant differentiation of x is 1. So directly you can write from here to here using product rule. So generally you don't go for this way, but you can, there are options. If there are number of product is more than 2, then product rule will take some time, or divide also, there are 5-6 terms, then log can be easy or handy. Now in case of function, suppose the function is climbing above another function. One function is above another function. It is in a power form. Gx on the top of f of x. So gx is in the sky. You cannot differentiate it in this earth. So if you want to differentiate it in your earth, in your home, in your room, in your study table, you have to bring it from sky to earth. So to bring it from sky to in earth or your level, you have to take log. Then only it will come down. So suppose one example, y is equal to x to the power sin x. So if you take log y is equal to log of this one. So log of x to the power this, what happens? This comes in front. I have discussed this property in logarithm function. You can check that one. So sin x will come here and then log x. So if sin x is there, then log x, then you do differentiation of 1 by y dy dx. Here it is sin x, differentiation of this one. This constant differentiation of this, product rule. So sin x constant differentiation of log 1 by x, log x constant differentiation of sin cos. So if you do dy dx, then y into this. So what is y? Y is x to the power sin x, so you put it like this. So this is your answer. This one is your answer. This is a question of Tripura University 2018. If you like the video, then press the like button and please give your valuable comments in the comment section.